Welcome to Nick Does Maths, boys and girls, everyone big and small, whoever you are, want to do some maths. Today we're doing a fun integral and we're going to use the t substitution, also known as the Weierstrass substitution. So let's remind ourselves of what, why and how. We have 2 over 1 plus sine x plus 2 cos x. Now there are ways around this using harmonic forms, but we're not going to do that. It's not actually that nice. So instead, we've got these sine x and cos x in the denominator. It's not particularly nice. So we know that we're going to look at this old chestnut. So we are going to use the substitution t is equal to tan of x over 2. Why would I do that? Are you insane? No, I am not. Right, sine x is 2 sine x over 2 cos of x over 2, because x is twice of x over 2. Now, I will delete some of this just to have space on the board, but if I multiply and divide by sec squared of x over 2, what do we end up with? I end up with, of course, that's 1 over cos squared, so I end up with 2 tan x over 2 over sec squared of x over 2. That is 2 tan of x over 2 over 1 plus tan squared x over 2. So that is 2t over 1 plus t squared. Similarly, let's just check cos x. That is cos squared x over 2 minus, getting ahead of myself. Come on, hand, do what brain says. Sine squared of x over 2. We can do the same trick. Multiply and divide by sec squared of x over 2. Cos squared times sec squared is 1. Sine squared times sec squared is tan squared of x over 2. Now sec squared, we're in the same situation we were here, so we end up with 1 minus t squared over 1 plus t squared. And finalement, we should probably look at our dt. So if we differentiate that, I get dt by dx is 1/2 sec squared of x over 2. So we can rearrange that in a second. All right, let's sub all of that in and see what we get. X is 0. T is tan of 0, which is 0. X is pi over 2. Tan of pi over 2 is tan of pi over 4, which is 1. So we've changed our limits. Smashing. 2 over 1 plus sine x is 2t over 1 plus t squared plus 2 times cos x, which is 1 minus t squared 1 plus t squared. Now, let's rearrange this for dx. If you rearrange that, you will get that dx is 2 dt over 1 plus t squared. Right. Let's multiply this through. 2 times 2 is 4. Isn't that nice? 1 plus t squared times 1 plus t squared. 2t over 1 plus t squared times 1 plus t squared is 2t. Those will cancel out there, so I end up with 2 minus 2t squared dt. Now then, this is 0 to 1. Now I'm going to bring a minus out, because I'm going to end up with a minus t squared. T squared minus 2t squared is minus t squared. I'm going to pop a minus out here. Plus 2t, 1 plus 2 Now, the reason for this is basically because I find it much, much easier to factorize this. That's why. Because that is t minus 1, t plus 1, t minus 3. So we can do some partial fractions on this. Let's find out what happens when t is 3. That's a minus 1. T is minus 1. So I think it's 1 over t plus 1 minus 1 over t minus 3. There we go. So of course, this integrates to ln. And actually, we do need the modulus sign. I'm usually a little bit careless with the modulus sign. Okay, a couple of steps here that I'm leaving you to do in your own time. All right, very basic partial fractions getting from there to there. Check it out, I'm sure you can do it. And again, I've just done 2 steps of integration, ln of t plus 1 minus ln of t minus 3, a little bit of ln mucking about there. So let's plug in 1. What do we end up with? If I plug in 1, I end up with 2 over minus 2. That's ln of mod minus 1. Well, that's 0. Plug in 0, 1 over minus 3. Well, that's just ln of third, so that will just become ln of 3. Written best I can down in that corner there. Skirt douche. Nice, chill integral. We start off, these are very good to have in your back pocket. Won't fib, I never remember them. All right, I know roughly what I'm looking for. I know there's a 1 plus t squared, but quite often if I find myself needing to use them out in the world as I do in day to day, I will just rederive them quickly like I do there. We don't have to remember everything so long as you know how to get them. And then the integral isn't too bad. Did you enjoy this? If you did, please don't forget to like, subscribe, hit the notification button, all the good stuff. Let me know how much you're enjoying this, doing the maths every day. I'm Nick, here doing maths. I will see you next time. Bye bye.